Hi to everybody, dear students, YouTube followers. I will begin with the test I made some days ago, these last days. Okay, I will do it in some videos, around 15-20 minutes each, because well, all one unit in one video, it would be too long. So first of all, you know that it's my first time doing this, so sorry for all the mistakes I will do for sure. Okay. Well, we will begin with the first unit. Is consumers' behavior, utility maximization problem, how the consumer demands goods, and so on. Okay. Well, the first question is the principle of transitivity of preferences says that if a rational consumer prefers bundle A to bundle B and bundle B to bundle C, then bundle A is the best bundle he can achieve. No. Bundle A is preferred to bundle C. That's what the principle of transitivity tells us. Okay. Maybe bundle A is not affordable. Okay. Maybe is not at his budget set, so he can't buy that bundle. So be careful, because this is a little bit tricky, maybe, but well, that's what we need to know. Okay, when we are talking about preferences, we don't talk about money. Okay, so mathematically we express it like this: the transitivity property preferences, we can write like this. Okay, if bundle A is preferred to bundle B and bundle B is preferred to bundle C, then bundle A is preferred to bundle C and to bundle B, into bundle C. Then at the end, the transitivity condition tells us that bundle A is preferred to bundle B. So clearly the true is B. Okay, but it's quite easy. Now, number 2. If I consume more of a certain good as my income increases, well, we should know that the good is normal good for me. It can be represented by the angle curve. The higher my income is, the more I consume from good X. Okay, the income elasticity would be positive. Okay, the higher my income, the more I consume. This also was easy for you, I think. I hope. The third one, the price elasticity of demand can never be negative. No, of course it can be negative. Almost always is negative for all the ordinary, so-called ordinary goods, that are those goods that verify the law of demand. So most of them measures the unit variation on demand for unit changes in price. No, this is the slope. So the derivative from the Q, from the quantity demanded with respect to P, is always negative. No, almost always is negative, as I told you, but not always. There exists some strange goods or strange situations where some goods could be giving goods. The more the price is, the more we consume. So the truth is D, clearly, is the percentage variation on demand when the change in price is written as a percentage also. Okay. Now the mathematical expression, we do it in our exercises by differentiation. This could be another point of view. This is the midpoint elasticity, is when we change from one bundle to another one due to an increase in prices, for example. Okay, we do it by subtraction, but well, normally we do the point elasticity and we do it by differentiation. Okay, now Number 4. The consumer always consumes 2 slices of bread for each slice of jam. So always like this. They are perfect complements to this consumer, okay? Clearly. He only lacks that proportion, but he could eat huge quantities of that kind of sandwich. The price of each slice of bread is 0.20 monetary units, and the price of each slice of jam is 0.30 monetary units. How much will he demand of each good if his budget is 1.40 monetary units? Well, the easiest utility function describing these preferences would be this one. Yeah, if 2 slices of bread are eaten for each slice of jam, then that number 2 we write it here as a coefficient of j. So the problem of the consumer is this one. This is a budget constraint, clearly, with the unit prices of each good and the income. And when we want to solve perfect complement exercise, we just find the optimum at the inks of that L-shaped indifference curves, as we know. So we equalize B to 2J here, okay? And we substitute it at the budget constraint. All these inks, all these vertex of that indifference curves, L-shaped indifference curves, verify this. So when we substitute it, we have 0.2 times 2j plus 0.3j is equal to 1.4. So 0.4 plus 0.3j is 0.7j equal to 1.4. So j is equal to 2. Yeah, and if I consume 2 slices of jam, I would like to consume the double, yeah, of bread, 4 units of bread. Okay. As I told you, always the perfect complements case is the easiest one, even with parameters. Yeah. In this case, it's a very easy exercise, and I hope you all do it. Okay. Number 5. A consumer always consumes 40% of her income M in good X and the rest in good Y. Well, these kind of preferences we know that are described by the Cobb-Douglas utility function. Okay, which utility function with which Cobb-Douglas utility function is appropriate for us now? Well, x times y, but with the exponents, for example, 40 and 60. Yeah. For example, this one, we know that x elevated to 4 times y elevated to 6 also would be valid, and more of them. Yeah. The consumer's goal would be to maximize this utility function. The budget constraint is this general one without numbers. Px, py, and m are parameters. Yeah, and we know, I told you many times, in fact, our first exercise in our presential classes is this. Derive these formulas from a general Cobb-Douglas case. A is the exponent of x, b is the exponent of y. So the solution, the demand for x is a, so 40, divided by a plus b, 40 plus 16, times m divided by px. So 0.4 times m divided by px. And for y, we have b, so 60, divided by 100, so 0.6, m divided by py. Okay, these are the solutions, these are the demands for good x and good y by this consumer. So the correct one would be this, okay, the C. Perfect. Now, exercise number 6. If the income effect compensates the substitution effect, the good is what? Well, we use here a very useful table I give you in class. Okay, the income, when I talk here about compensating, I'm talking about a different sign and in absolute value higher than the substitution effect. So when I talk about compensating, I talk about the opposite sign and higher quantity, so that the sum becomes positive. Okay, here, I mean, inferior goods, they have substitution effect as all the goods except special ones, they are perfect complements. Perfect complements, they have zero substitution effect, but the rest have negative substitution effect. Well, so when I talk about compensating this effect, I'm talking about the possibility of the income effect being higher than in absolute value that the negative sign of the substitution effect. So the sum becomes positive. That happens to given goods. Okay, perfect. Now, seventh question. If the income effect opposes the substitution effect, the good, well, when I talk about opposing, I'm talking about just that the sign is different, yeah, from the substitution effect, that the signs are different. So the substitution effect, we know that it's always negative, so the income effect should be positive. In which type of goods happens this situation, inferior goods? The point is that here I didn't tell you inferior goods, so as an option, yeah. So the good could be given good or could be ordinary good, as we see on tables, yeah, in the table, sorry. So the answer is D. I hope you understand this. With the table, it's very easy. We know that income effect, substitution effect, they are not very easy concepts to understand. I will try to explain it in other questions, but in this type of questions, that's the reason why I give you that table. We could find the answer just looking at the table. Number 8. A commodity that is bad lowers the utility level of a consumer as he consumes more from it. Yes, of course. The more I consume one commodity, the worse I am, so that's bad for me. Has negative marginal utility? Yes, because marginal utility is the derivative of the utility with respect to a good, with respect to, for example, y. So if it's negative, it means that the more I consume good y, the less my utility level is. So it's a bad for me. Then the correct option here should be D. Again, well, I put you here a graph. I will try to explain it. If I set a certain consumption level for y, for example here, and I consume more from x, so I go utility level 1, then utility level 2, utility level 3, etc, etc. So I am better off, yeah. But if I fix a certain level of consumption of x, for example here, and I consume more and more and more from good y, we can see that the utility level 3, 2, 1 decreases. So I'm worse off the more from good y I consume. This could be the representation of the indifference curves in such a case. Okay. Well, two bundles laying at the same indifference curve tell us what? This is very easy. We just have to know the definition of indifference curve, that is the set of points in the plane, or the set of bundles, that the utility level in all of them is equal. It's equal, for example, to a certain value k. So the two bundles are laying in the same indifference curve tell me that both are equally preferred. Yeah. Well, the cost of buying them is the same now. That would happen in the budget constraint, well, with two bundles in the same budget constraint. And C, be careful with this C, because this sentence is true if both commodities are good, yeah, but this is not related with what the assumption or of the exercise 9 tells me. Okay, so be very careful. Be careful. Well, if two bundles A and B are at the same indifference curve, then they give me the same utility level, K for example, so they are equally preferred for me. Well, we will leave here the first video, and we will continue with the 10th, okay, with question number 10. Thank you very much.